Hello guys, so now I'll be explaining the algebra for the AMS tomorrow. I'll explain it a little more deeper. So what we're learning in this algebra is called the absolute function. Absolute function, from its name, it means that f(x) is equal to the absolute value of x. So the graph will look something like this, alright? Also, instead of f(x) is equal to absolute value of x, we can say that y is equal to the absolute value of x. Or that f(x) is equal to y. So whenever you see any of these three and you see the graph is a perfect V shape, then you know that it is an absolute function. Alright? An absolute function, f(x) is equal to y is equal to absolute value of x, and f(x) is equal to absolute value of x. Now, this is the absolute function. Let us then talk about what? Talk about stretching and shrinking. We have a graph, we will put it in red. Always remember, in the exam, the original is in red. Okay? In the exam, the original is in red. So we know that the function of the graph is f(x) is equal to the absolute value of x, or y is equal to the absolute value of x, or f(x) is equal to y. Whatever you want to put is correct. So let's say we're going to take y is equal to absolute value of x, because it's very simple, very easy. If we multiply the absolute value of x by a number a, there will be something called stretching or shrinking. So the graph will stretch if a is greater than 1. So for example, 2, 3.5, 4.7, etc. Whole numbers, fractions, decimals, anything that's greater than 1, it will cause a stretching. So the stretching, I will do it in pink. It will look something like this. Okay? Then we have something called shrinking. Shrinking is when a is in between 0 and 1. So a is greater than 0, but it is less than 1. Meaning it can be 0.5, 0.7, 0.66, something like this, whatever. As long as it's between 0 and 1, okay? So this is what we call shrinking. Shrinking will do what will do? It will look like this on the graph. Alright, so the red is the original, the pink is the stretching, and the green is the shrinking. So this is it for the case of stretching and shrinking. Now we have something called the vertical shifting. We have another graph, okay? And always our function is gonna be what? It's gonna be the absolute value function, which is that f(x) is equal to absolute value of x, or f(x) is equal to y, or y is equal to absolute value of x. So what happens if we add a number to the function? For example, we're going to take f(x) and we're going to add 2 to it. Okay, or we took y and we added 2 to it. So what happens if we add a number to the f(x) or the y? It is called vertical shifting. So if you add a number to the f(x) or the y, okay, this is called vertical shifting, meaning it will shift about the x-axis. Sorry, it will shift about the y-axis. This is the y-axis. This is the x-axis. So it will shift about the y-axis. So let's say plus 2, it will go up what? The original graph will go up 1, 2, so it will be here now. And this is what it will look like. But for example, if they told us what? f(x) minus 3 or y minus 3, we will go down 1, 2, 3 here, and then the graph is the same, but it went down vertically. If you see it like this, it goes down vertically or it goes up vertically along the y-axis. So this is for vertical shifting. Now, of course, we have vertical shifting and we have horizontal shifting. So let's take the basic absolute function. So fx is equal to the absolute value of x, y is equal to the absolute value of x, or fx is equal to y. Horizontal shifting means what? Means you're adding or subtracting a number from the x. So it's gonna be fx plus or minus, for example, h, a number h, or absolute value of x plus or minus h. If we have a case like this, if you see that they're adding or subtracting a number and it's affecting the x, and like that means it's inside the parentheses or inside the absolute value, we call this horizontal shifting. Okay? So let's say they did fx minus 6. Okay? What we are gonna do is that we're gonna take the opposite of the number. So 6. What's the opposite of, minus 6. So what's the opposite of minus 6? 6. So we're gonna move 6 units. That means 1, 2, 3, 4, 5, 6. So now the graph will be over here. But if they told us, for example, fx plus 3, we're gonna take the opposite of plus 3, which is minus 3. So we're gonna move 1, 2, 3. So here, this is where our graph will be. So if it is a horizontal shifting, if it's inside the brackets minus, we move it to the right. If it's inside the brackets plus, we move it to the left. So this is it for the horizontal shifting. Now we have something called reflection. We have vertical and horizontal reflection. So let's take the absolute value function again. Fx is equal to absolute value of x. Fx is equal to y. Y is equal to absolute value of x. These three, they mean it's absolute value function. Now we know the very first thing we did was multiply the absolute value, but what happens if we multiply our function by minus, by negative? So usually if you multiply it by a number, it will stretch or shrink depending. If the number is greater than 1, it will stretch. If the number is between 0 and 1, it will shrink. But what if we multiplied the function or the absolute value by minus? What happens? A vertical shift. So now it is minus fx, or it's equal to minus absolute value of x. Whenever we multiply by minus, we're gonna do a vertical reflection. What does a vertical reflection mean? A vertical reflection means a reflection about the x-axis. So you go to the x-axis, you see, oh, this is our graph, so I'm gonna do a shift about the the x-axis. So the x-axis is my mirror. If we were to do a reflection, it would look like this. So this is a vertical reflection about the x-axis. Now we only do a vertical reflection if we multiply it by negative. We multiply what? We multiply the whole entire function, meaning the number. So if it was, for example, 4x, you multiply minus by 4x, you will get a vertical reflection. Now, what about a horizontal reflection? We're gonna draw the graph again. And I will write fx is equal to absolute value of x, y is equal to absolute value of x, y is equal to fx, or the other way around. So what happens if we put a minus here, or a minus to the y? So it's gonna be either f minus x or minus y. I don't think actually minus y works. So let's stick with the f minus x. If we see that it is f minus x, we're gonna do a shift about what? about the y-axis. So here, if you would do a shift about the y-axis, it would not change place, it would be the same. But let's say, for example, we had another graph. Let me draw another graph over here. Okay, so let's say we didn't have fx is equal to absolute value x. Let's say we had let's say we had fx minus 2. So usually fx absolute value of x would be here. Its vertex is at 0. But fx minus 2, we're gonna move it 2 units to the right. First of all, we're gonna take the opposite of minus 2, which is 2. And so we will move it 2 units. 1, 2. So now here is what it looks like. So if they told us f minus x minus 2, so what did they do? They multiplied the x by negative. What we would do? We would go 2 units but in the opposite side. So we're gonna do a horizontal reflection. So it would look something like this. So if they asked us how do we obtain the f minus x minus 2, you can say either by doing a horizontal reflection of fx minus 2 or moving 2 units to the left. Alright, now why 2 units from the left? Because originally, so the original graph is what it is, the absolute value of x. So if you notice, this is what the original graph would look like. But if you notice, it is where it is 2 units to the left. So it's a shift of 2 units to the left. Now this is for the horizontal reflection. Now I'm gonna be talking about a general equation, which is y is equal to a absolute value k minus h plus y is equal to a absolute value x minus h plus k. This is what a general rule for the changes in the absolute value. So the vertex, if you cannot find the vertex, what do? You take the minus h, take the opposite number of it, h. Then you take the k, you keep the k the same as it is. You don't take the opposite number, you just take the k. And like that, you found the vertex, your h and your x and your y. So your vertex is gonna be h. K, what does it mean? If your absolute value function is going in the opposite direction, for example, it looks like this, like the arrow is pointing downwards, or it's a V shape, okay, then HK is the lowest point. Alright? However, if your absolute value function looks like this, then HK is your highest point. As my math teacher says, here it's like you are going down the hill. So here is the lowest point of the hill, and here it's like you're going up the mountain. So here's the highest point of the mountain. So again, to find the vertex of, so if they ever ask you to find the vertex of this function, you would take the opposite of h, the same value of k, not the opposite, the same value, and then you have your vertex. How to know if it's the highest point or the lowest point? You have to look at your graph, you have to check your graph. Or another way you can do is check here, is it minus or plus? It's plus, so it's gonna be the lowest point. If it's minus, then it's gonna be the highest point. So this is how to get the vertex in the basic changes of the absolute function. So let's say again we have y is equal to a times the absolute value of x minus h, alright, plus k. This is the basic changes to the absolute value function. So the domain for this function is all real numbers. There's no exception, because if you try to find the domain, it's going to be all real numbers. Now, The range depends on A and K. So the range will be greater than or equal to K if and only if A is greater than 0. And however, Y, the range Y will be less than, here I'll write range so we don't mix up, Y will be less than K if and only if A is less than 0. Alright, then we have something called the axis of symmetry. Axis of symmetry means where they are symmetrical, where this side is equal to this side. You reach the axis of symmetry when x is equal to h. And always watch out, your x, its value has to be 1. If it's not 1, you have to make it 1. If it's 1 over 2, you multiply it by 2. If it's 4, you divide everything by 4. Whatever you do, you have to keep your x 1. So that's it for the shifting for the algebra for this week. I hope you guys enjoyed and have a great day.